All right, now we're going to look at right point method for Riemann sums, and the best way to understand this is to compare it with left point. You notice this first rectangle has a height determined by this right point of this with this interval right here. So if we're going to choose between -2 and -1.5, we choose the point on the right to determine the height of this rectangle. We basically just go down until we hit the graph, and then we draw a rectangle in. If you compare that with the left point method, we started with this left point -2, we ignored -1.5, and we drew the height of our rectangle based on going down until we hit the graph. We can see this one has a much higher height, or a taller height. So that's the difference between left and right point. Right point, you use the right point to determine the height. Left point, you use the left point. Now with left point, we did not use this last x value of -2. We used, +2. We used 1.5 to determine the height. With right point, you will use this last value of 2, and you will go all the way down until you hit the graph, and you will have that last rectangle drawn in. So the only real difference between left point and right point is with left point, you start with the leftmost value and you ignore the rightmost. With right point Riemann sums, you ignore the leftmost value for your height, but you do end up using the rightmost. You end up with the same number of rectangles, it's just a slightly different method, so you're going to get a slightly different estimation. Now we're going to do this the conceptual way again, and again we're talking about total area right now, not net area. If this were net area, we would determine all of these rectangles below the x-axis to have a negative area. But for right now, we're just going to say that they are positive. So determine the area of the first rectangle for right point method. We will start with that right x value of -1.5. Determine the height, we just go down until we hit the graph. So to figure that y value out, you plug in -1.5 into this function. Then you multiply by the width, which is 0.5. And when we do that, we get 0.625, which will be the area of this first rectangle right here. Okay, then we will move to the next x value, which is -1. Now the height of that's just going to be 0, because 1 minus 1 is 0. 0 times a half is 0. So we will have that. The next rectangle will have an area of 0.375, this one right here, which is determined again by the width of this rectangle times the height. So we'll plug in -0.5 into our function 1 minus x squared, take the absolute value of that, and multiply that by 1/2 to get 0.375. The area of the next rectangle will be 0.5. We can easily see that it's 0.5 because it's 0.5 times the height, which is 1. And we are going to go all the way down until, like I said, the very last x value, which is 2, and we will determine the area of that rectangle by 1/2 times the height of it, which is 3, which you can easily see on this particular case because it crosses the grid right there at 3. So it's 1/2 times the height, which is 3, and we get 1.5. So the total area, if we add up all of those rectangles, we're going to get 4 again, which is exactly the same thing we got for left point. Now that usually doesn't happen. Part of that has to do with the fact that this graph is symmetrical. But I'm glad I did it that way because left point and right point really don't have an advantage on each other unless you're talking about a particular graph. In general, they're going to give you about the same amount of accuracy. So we did get 4 for both of these, but what I really want to look at is, how to do this every time, step by step, just like we did with left point. So for right point, the steps are going to be very similar. Like I said, one key difference. So what is the area between the curve of this function and the x-axis on the interval -2 to 2? Step 1 is to determine the interval length. And again, you start with your rightmost x value and you subtract your leftmost. That gives you the width of the total interval. It's going to be the same as before, which is 4. Next, we're going to determine the number of rectangles. So in this case, there are 8 total rectangles that we're going to go by just based on the, comparing it with left point. Again, the next more detailed number of rectangles you could go for is 16. In that case, each rectangle would have a width of 0.25. But we're just going to go with 8 for now. If we went with 4, it just wouldn't be accurate enough, so we're going to go somewhere in the middle and choose 8. If you take 4 and divide by 8, that will give you the width of each rectangle for step 3. So take your interval length, divide by the number of rectangles to get the width of each rectangle, which is 0.5 or 1/2. Step 4, you can see the x values are going to be different for right point method. You're going to use all the x values except for the first one, because the first one is your leftmost point. So you ignore that, but you will use all of the rest of them. So from negative 1.5 all the way to 2. Notice you still use the same number of x values. You use 8, but in this case you're ignoring x naught, your initial x value. You're including all the rest of them. And then from there you just do the same thing with left point. You find all the height of the rectangles. Okay, so basically what you do is you find all of these heights, okay, and you add them up and you multiply by the width of each rectangle, because rather than having to just multiply by the width each time, you can just pull that out as the GCF, add up all the heights, and then multiply by the width at the end. So we would determine all the heights by plugging in all these rightmost points. And again, we're going to just talk about absolute value for now. We're not going to consider the anything below the x-axis as negative. That's net area, which we'll talk about later. Right now we're talking about total area. So we'll take the absolute value of all these y values. That's step 5, and so you're just plugging in all these x values into your function to determine those, taking the absolute value. Step 6, we will add up the height of all of these rectangles, and we get 8. But we have to multiply by the width for step 7 to determine the area of all of our rectangles. So total area would be 4, which again is going to give us an estimation. If I go back to my left point lesson, it's going to give us an estimation of the total area between the graph of this function and the x-axis from -2 to 2. We add up these areas. Now again, if we were talking about net area, we would actually take this orange area, which is above the x-axis, and subtract this pink and this purple area. But for total area, you actually, take the absolute value of your rectangles, because you're going to determine you're going to basically consider that all of them have a positive area. So that's it for right point. You can see it's very similar to left point, except you ignore the leftmost point and you use all the ones after it. If you have any other questions about right point Riemann sums, let me know.